Hey guys, this is Professor Roldan with College Algebra review of Chapter 2, Sections 1 through 4, which is basically Part 1. Okay, so we want to go ahead and go through these one by one. You're welcome to use this as you do your own practice tests. They should be in the same order, maybe slightly different. So let's get started. So let's take a look at number 1 here and determine whether the relation is a function. And so you need to remember no repeating x's. Okay, if there is a repeating x, then you don't have a function. Okay, so no repeating x's will translate to a function. Okay, so we have 1, 2, 3 for the first parts there. Those are all different, so this is a function. Okay, the domain will be the x values. So that will be 1, 2, and 3. And the range will be the y values. And that will be 1, 2, 3 as well. Okay. So yours should be very similar to mine. And you can just do this one by one. And we're going to go to number 2. Okay, number 2 is determine whether the relation is a function. Again, same question. This time we have a repeating x right there and right there. And we have a repeating x right here, right here. So 2 times this is ineligible to be a function. Okay, so this is not a function. Okay, and so now we're going to go ahead and list the domain. Now when listing in both of these cases, we don't no repeating numbers. Whoops. In a list. Okay, so we cannot do 1, 1, 8, 8 for the domain. We just need to write 1, 8. I'm sorry, 1, 1, and 1, 8. Okay. Okay, so you cannot repeat those values. And in the range we have 4, 9, 4, and 9. So this is going to be 4 and 9. Okay. Next we have number 3. Evaluate the function. So keyword here is evaluate. That means we have an input of 1 into our equation. We have input of x plus 6 that we're going to put into this equation. And we have an input of negative x that we're going to put into this equation. So input, and it's asking for the output. So you input the 1. What is the output? The output is 8 plus 7 is 15. Okay, so that will go here. And then here we have an expression as the input. So we're going to go ahead and distribute the 8 to get 8x plus 48 plus 7. And then we simplify these two right here. So our final answer should be 8x plus 55. Okay. And then you put a negative x into this one. So that's going to produce just basically a negative 8x plus 7. And that's our final answer. And that's how you evaluate a function. Okay, let's go to number 4. It says graph the given functions f and g in the same rectangular coordinate system. Use the integer values of x given to the right of the functions to obtain ordered pairs. Okay, so we need ordered pairs. We have x values already given. Describe how the graph of G is related to the graph of F. So here's our given values, which they're already put right there. So f of x is basically, we're doing the square. F of x is, f of x is the square root function, right? And this is x plus 5. So we're going to do the square root of 0, which is 0. The square root of 1, which is 1. Square root of 4, which is 2. Square root of 9, which is 3. Okay. Then the next one is basically the same values, except we're going to add 5 to each answer. So basically this is going to be 0 plus 5, which is 5. This is going to be 1 plus 5, which is 6. 2 plus 5, which is 7. And 3 plus 5, which is 8. Okay, so those are our values. And now we have ordered pairs. And now those ordered pairs are going to be graphed. Okay, so the parent function for square root of x is basically centered at 0, 0, 0, right here. This is the origin. So if we look, okay, f of x, let's zoom in a little bit more. So f of x is the blue one. So we have 3 that have three of them are correct for the square root of x function, and this is incorrect. Then if you look at the red function, we have to increase everything by 5. So all of our values will get increased by 5. So that means it's gonna go shift up by 5, and this is the right one. Okay. So for my example here, the answer will be B. And then describe how this graph is related to the graph of F, and we saw a shift up 5 units. Okay. All right, now we're going to use the vertical line test to determine if y is a function of x in the graph. And basically, there are no spots where this thing hits twice. So this is a function. This passes. So this is a function. Okay. So this also is, this is the visual of the no repeating x values condition or requirement that we talked about before. Okay, number 6 is use the vertical line test to identify graphs in which y is a function of x. So this obviously fails the vertical line test in a bunch of places. The only place it passes is like right there, but everywhere and right here as well. So 2 places that pass, it doesn't really matter. If there's only 1 place that it doesn't pass, like all these other places here, then it's not a function. Okay, so let's take a look at number 7. Use the graph of f to find the value of f of 5. So remember, this is the x value or the input. So that's what we're going to go look for. So we can find the y value. So remember, the x value is the location, and the y value is the amount or the value, how high or low it goes. Okay. So the y value would, so how high or how low. Okay. All right, so let's go to the location of 5 for x, which is right there. And we're going to go up, and it's right here. So there's our location. That's our location. This is our value. This is how high the function is at that location, and it is 3. Okay, so our answer is right there because we were given the x and we found the y. Similar question for number 8, but it's in reverse. So this time they want to know the location. What's the location or the x value when the height is -4. Okay, so the -4 is down here. This is how high or low the function is. All right, then we just got to go across. So they gave us the y value, and then we're going to go up and see the x value, which is a 7. So the location where the g of x is -4 would be at x equals 7. Number 9 says use the graph to determine the following. All right, so we need to know the function's domain, range, x-intercepts, y-intercepts, and the values at x equals -2 and 1. Assume that the graph of the function continues its trend beyond the display coordinate grid, okay? So that's an important assumption, okay? This is just a limited viewing window of 10 by 10. Okay, so basically the viewing window is limited, but the arrows tell you that it keeps going forever this way, forever that way. So the domain, there is no limitation for the domain. It goes forever to the left and forever to the right. And this is interval notation, okay? You cannot put all real numbers. What is the function's range? Again, there are no limitations going up, but there are limitations going down. So if you look right here, that is a 2 for the y, and that's how low the function goes. Okay, so you always start with the lowest, and it equals 2, and then it goes into infinity. Okay, x-intercepts, as you can see, there are none. Okay, it never crosses this y-axis, or x-axis, sorry. And the y-intercept would be, if we zoom in, that would be a 3 right there. So this will be at 3. Now, we're going to go to the locations of -2 for x and 1. So let's erase this, and let's check out -2 and 1. So -2 would be right here. So we're going to go up, and that's a 3. And for 1 is right there. We're going to go up, and that is a 4. That's how high the function is at those two locations. So the first answer is 3, and the next answer is 4. All right, number 10. We have f of x and g of x. Find two things. First, g of 9. Okay, this is the first part of the question. So we're going to input 9 into our linear equation here. So that's going to go right there. So that's going to be 18 plus 9, which is 27. So that's g of 9. Now, the next question is asking, okay, what is f when g is 9? Okay, or g of 9. So this right here, we already know the answer to this inside part is 27. We just calculated it. Okay, so we're going to put the 27 inside the f. And the 27 is x squared minus x, the f of x, yeah. So we're going to put that 27 right in here and right in here. Okay, so we have 729 minus 27 plus 2, which all that equals 704. Okay, so this one was asking you a particular question about g. Input 9 into g, and then that answer, whatever you got, is going to go inside of f. Okay? All right, so we are here on number 11. Use the graph to determine open intervals on which the function is increasing, decreasing, and constant. So first let's do increasing. So increasing from left to right, remember we're going uphill. So if you think of you go walking uphill here, so this will be increasing. Okay, and that stops increasing right there at the maximum, and that is at x equals -1. So x equals -1, all right, is the location on the domain where this function stops increasing, and it changes from increasing to decreasing. So that is going to be, so from -infinity, it's increasing all the way up to -1 for the domain, and that's open interval. Okay. So we're not thinking about how high it is. We want to know the location of this spot here. So to put it in another way, let's see here. So it's this domain right here, and then the other side of this domain over here, this is going to be the decreasing side. Okay, so left increasing domain, and then the decreasing domain, because our function is going downhill. So think of a person walking downhill. So that's going to be right here as well, from -1 to infinity. Okay, and then, so that's decreasing, and then the constant, well, there is no interval. Okay, where's constant? Number 12, maxima, minima, relative maxima, relative minima. So let's take a look at this word first. So we can see that although these go forever and there is no maximum there, that there is a relative maxima right there. In this general location, it reaches it gets maxed out. Okay? So remember, there's always two numbers to every coordinate. We have the location, which is -3, and then we have the height. Okay? So when it says, what are these relative maxima, it says find the numbers at, that's at the location, which F has a relative maximum. So we have at, that's location, so that's X values. So that's going to be, I think you can put it just, see, use a comma to separate answers, so you just need to put a -3. So that's the location. Now what is the height of that? And if we zoom in, we can see that that is a 4. So the height of that maxima is 4. Okay? So this is R, is the value or the height. Let's do that. And that's the Y value. Okay? Now let's do relative minimum. So we're going to take a look. These two has two spots, right here and right here. So those are the two locations, -4 and -2, that there is a relative minima. Those are the locations, as you can see, both are at the value of 0. So the locations we need to put first. So that's -4 and -2. And then the actual value or the height of that minimum is 0. It's on the x-axis, so that would be 0. Okay, so that's taking a look at that relative maximum and minimum. So now we want to take a look at determine if the function is even, odd, or neither. Okay, so if you remember, if you put in a -x, okay, do you get same function? Or do you get the complete opposite function? So if you get the same function, that's going to be even. If you get opposite functions, that's odd. Okay? Now, what's going to do the trick? Well, what makes something the same function is even powers. Those make your negatives back into positive. So negative times negative is positive. So these two are both odd. Therefore, this is going to be odd. Okay? Both odd, that means it's odd. Okay? And these two here, one is even. Actually, this one's even. This one's odd. So the first term, the 12th, will make that negative turn into a positive, but then the odd power will actually leave it we'll change this positive x to the third into a negative x to the third, giving it the opposite effect. So this one does not create either or, so it's going to be neither or neither. Okay, and if we look at 15, odd. So basically, another way of saying odd would be, so odd would be symmetry. On the origin. Okay, even would be symmetry on the y-axis. Okay, so this would be sort of like this, or like this, and then this one would be more like this here. So if you look here, this is definitely symmetrical to the y-axis right here. The y-axis is acting like a mirror, and it's reflecting whatever is over here, over here. Okay, for all the points. Okay, and you can see just by looking at the numbers that the opposite x was given right there, and we got the same y's. Okay, so that's just another way of looking at it. So we put the opposite x, and we got the same y's. Okay, so this is the answer to this one would be even. Okay, just like the x squared function, which looks like this. Okay, it's the same concept. Okay, number 16 has a bunch of questions here. It's got domain, range, intercepts, increasing, decreasing, constant, minimum, and even, odd, or neither. So let's take a look. So first one is domain, and I think I'm just gonna answer them here. So domain, as you can see, the function exists everywhere, forever to the left, okay, and forever to the right. There's nothing stopping it. So this is going to be negative infinity to positive infinity. The range goes forever up, but does not go forever down. And we have a spot here. And if we go across, okay, so if the bottom is negative 6, that has to be negative 4. Okay, so our lowest y value, or the lowest value of the function, okay, not the location, but the value this time, all right, is going to be negative 4, and it's going to go all the way up to infinity. Now, x-intercepts, we can see that that's 1 here and 1 here. So that's going to be 1, 2, 3, and 7. So okay, y-intercept would be up here, and that is 18, 19, 20, 21. So that is a 21. Intervals on which the f is increasing, decreasing, constant. So first one is increasing. That would be what is this? 3, 4, 5. So right here at x equals 5, it increases. So that's going to be 5 to infinity. And the decreasing would be from x equals 0 all the way down to 5. Okay, for the domain. This is all about domain. And everything is open as well. And then you can see the constant interval is from 0 all the way to the left. So it's all this right here. Let's see here. Okay. All right, now let's take a look at all the discussion about minimums. So there is a relative minimum right there, and that is, as you can see, it's the location of 5 with the value of 4. So it says the number at, that's the location, so that's going to be x equals 5. And the actual minimum value is y equals -4. Okay. This time they want to know what is the value at the location -2, which the -2 will be anything negative. So right here is going to be the same value anywhere, and that's 21. So this is 21. The values of x for which f of x equals -3. So that's that is the height. So we're going to look for the height of -3, which is right here. 2 locations, there and there. So that's 4 and 6. 4 and 6. Whoops, I meant to put x. Alright. And then, is f even, odd, or neither? And it's definitely not symmetrical to anything, so that would be neither. Okay, so this is all the questions that we can ask and analyze for a specific function like this one. Okay, so here we have a piecewise function, and all this is 2 lines. I mean, in this case, it's 2 linear equations sharing the same coordinate system or coordinate plane, and x is less than 0. That means it's negative, or the left side of the graph, and x is equal to or greater than 0, so that's 0 or positives, which is basically the right side. Okay, so this is the left graph, and this is the left graph, and this is the right graph. So -1 is definitely on the negative side, so that's going to be, we're going to give this -1 to the first one, which is this guy. And then x equals 0, that's going to be the second function. And f of 1, that's going to also go to the right side, or the second function. So this one's going to be (5 times -1 plus 5), which is going to be -5 plus 5, which is 0. And then f of 0 is going to go into 4x plus 7, which is 7, and then f of 1 plus 7, 4 plus 7, and that's 11. Number 18, the domain of the piecewise function is negative infinity to positive infinity. First, graph the function, and then use your graph to determine the function's range. Okay, so again, we have this. This is the left side of the graph because it's less than 0, and this is the right side. Right side, actually, in the center because it equals 0. So we know that this has a negative slope. So look for the graph that has a negative slope on the left side. This is positive, so that can't be it. So there's a negative slope right there. I'm sorry, that's not a negative slope. There's a negative slope, and there's a negative slope. All right. So for the right side, it's a positive slope, right? Because that's 2x, positive 2x. So that right side should be going up or increasing. This one is not increasing, it's this one right here. Okay, so there's your negative 2x right there, and there's your positive 2x right there. Okay. All right, so now let's answer the range. So the range, we can see it bottoms out right here at 0. And it goes forever up, because those assume to be, that's just a viewing window, so this thing goes forever into infinity. So number 19 says find the slope of the line passing. So we need to find the slope passing through the points given below, or state that the slope is undefined. Then indicate whether the line through the points rises, falls, is horizontal, or is vertical. Okay, so we're looking for, is it going to rise? Does it fall with a negative slope? So that's positive slope, negative slope, horizontal, or is vertical. This is 0 slope, and this is undefined. So, slope among various things is going to be rise over run, which is the difference in the y's over the difference in the x's. So we have, we call this our first x, our first y, second x, second y. So we have 9 minus 5 and 5 minus 4. So 9 minus 5 is 4, and 5 minus 4 is 1, so this is going to be 4. And then this is definitely not 0 or undefined. This is a positive slope. This is going up from left to right, or rising. Okay. So let's take a look at number 20. Find the slope. Well, this is basically the same question, except here we notice that we have a repeating y value, and that just means that we can anticipate we're going to get a 0 for the y, the difference of y's, which if we run for the formula, is on top. So basically, if we have a 0 on top, it doesn't matter what's on the bottom, this is going to be 0. Okay? Now to prove that to you, we can go ahead and put it in the formula. So negative negative 5 plus, sorry, negative 5 minus a negative 5, and negative 7 minus negative 9. So they're both pluses. And there's your 0. Okay, which we did not have to do because we can see that we have the same y values, and that means there's no change in y. There's no rise. Okay, so this means there's no rise, and if there's no rising, 2 points will be going like this. There's running, there's definitely a run, but there's no rise. Okay, there's a run of 2, there's no rise. So if this is not necessarily showing your work, because that can be spotted out pretty quickly there with the repeating y's. So this is definitely horizontal. Okay, and if you would have had if the negative 5s would have been in the x coordinates, then we see that there's no running, there's only rise. So that means repeating x's. Oh wait, we talked about repeating x's before, and that's not a function, and it fails the vertical line test. And there's an example of that. Okay, so let's go to 21. This is write the point slope form of the line's equation to satisfy the given conditions. Then use the point slope form of the equation to write the slope intercept form. So they're making us use both equations, or two out of the 3 equations that we talked about in class. So the point slope would be that's not right. Because we don't have 2 points, we only have 1. It's using the slope formula and moving the x, the difference of the x's alongside the m, or the slope. So we have our m right there, and we have our x, and we have our y. So y minus 4 equals 4 x minus 5. So we're done with the first part. That's point slope. We don't have to simplify that. But the next question just requires us to isolate the y. So this is part 1. And then part 2 would just be to get this y isolated. Or solve for y. So we're going to distribute. So let's get these rewritten here. We're going to distribute the 4. And then we're going to add 4 to both sides. And now we're done with part 2. Okay, so part 1 and part 2. Number 22, the only 2 pieces of information given is 2 points. There's no slope. So we do need to get the slope first. We need to find m. So use the formula for m, or the slope. And that's going to give us -3 minus 12 and 2 minus -3, which the bottom becomes plus. We got -15 over 5, which becomes -3. Okay, so that's M. Now we just pick either point. I'm going to just pick the ones with the smaller ones. So now you can use slope intercept or point slope or whatnot, but it asks us a particular form, so let's just go ahead and use it. Okay, so y minus a -3. -3 is the slope, x minus 2. And all we need to do is just clean up this part right here. So final answer would be y plus 3 equals -3 times x minus 2. So we're done with part 2. Part 3 is asking slope-intercept form. So we just go ahead and clean this up here. Okay, and that is it for this question. Okay, so now we've reached our graphing portion. So we're going to use the equation for slope-intercept. Y equals mx plus b. M is slope, and b is the y-intercept. And this is also rise over run, and this is also the coordinate 0b. All right, so we can see this is where we're going to start. Actually, I'm jumping ahead of myself here. We need to answer the questions. Well, the slope of the line is right there. So that's -6, and the y-intercept is 5. Okay, then we're going to use our information to start at 0, 5. That's on the y-axis. And from there, the slope is a ratio. It's a rise over run. So if we don't see the number, we go ahead and put it over 1. So this means we're going to go down 6, 1, 2, 3, 4, 5, 6, and over 1 right there. Okay, and we can just keep doing that. 1, 2, 3, 4, 5, 6, over 1. Or we can go back up the other way. 1, 2, 3, 4, 5, 6, go back 1. And then you just connect the dots here. And there's our line. Same question for number 24. So there's our y-intercept right there. That's where you start, and then we go down 4 over 9. So we're going to start at 4, and we're going to go down 4 over 9. All the way to right there. Okay, I could do one more. and I can go up 4, back 9. Just to kind of get more points, and we be able to do this line much better. Especially if you're doing this on a piece of paper. Okay, number 25. This is saying the slope is 0 because that's why you don't see any x term. Okay, x term is missing. That's because it's gone. It's times 0. All right. So this is also saying that the graph is always -6 for y. So here's -6 for y, and it's always there. So it doesn't matter where you go, it's going to be the same thing. So that's just in case you forget that this is horizontal, or a horizontal line. Okay? Now the opposite scenario will come up in the next question, number 26. So the opposite scenario, number 26, is the graph is always -8 on the x. It's always x equals -8. So here's -8 for x, and it's always -8. So that means it doesn't matter if you go up or down, it's going to be -8. Okay, and that should just tell you that this is a vertical line. Oops. Okay, so know the difference between those two. Then we have rewrite the given equation in slope-intercept form and then graph it. So that's asking you to basically isolate the y. Okay, so we need to go ahead and add 20 to both sides. Then move the 5x over to the right by subtracting it. And you can just go ahead and move that first if you want to. And then divide everything by 4. Or divide both sides by 4, so that's going to be y equals -5/4 x plus 5. Because you're dividing the first term by 4 and the 20 by 4. Okay? So we're going to start at 5 and go down 5 over 4. So down 5 over 4. And there's our equation. Number 28 says use intercepts to graph the equation. Okay, so remember, when you see it like this, a and the x and the y term on the same side, you want to go ahead and find the x and y intercept. This is great for that. You don't have to switch it over to y by itself. You don't have to do rise over run. Basically, we want to go ahead and find the x-intercept and the y-intercept. So first of all, we need the c to be on the right side. So we're going to add 36 over here. So we have 9x minus 4y equals 36. And the x-intercept is going to be whenever y is 0. So basically, that y term is going to disappear, leaving you with just 9x. So really, you can just do 36 divided by 9, and that's going to be 4. So now I can take this 4 and graph it right there on the x-axis. And then I can do the y-intercept and say, okay, what if x is 0 instead of the y? Well, that's going to make that term disappear, leaving you with the y term. You just divide 36 by b and get negative 9. Okay, which is right there. And then graph these two, and we're done. Okay, so this is another way to graph without using slope, because all we need is 2 points. If we can find both intercepts, that's 2 points. We connect the dots, and we're done. Okay, number 29. We're going to use the fact that parallel and perpendicular lines tell us something about the slope. So remember, parallel line is the same slope, and perpendicular lines have negative reciprocal slopes. Okay, so here they give us the word parallel. They give us x and y. So this is the clue for slope. We're going to use the same slope. Same slope of what? The same slope of this guy right here. This is a different line, but it's the same slope. So we're going to use negative 5 as our slope. So that means we're going to use m equals negative 5. Now, it asks us to use to put them in 2 forms, point slope and then slope intercept. And we can do both. So let's do y minus our y, which is negative 2. The slope is negative 5 times x minus a negative 2 as well. Both of those become positives. So we have y plus 2. And then we're going to, let's just rewrite this and distribute. So negative 5x minus 10, and then subtract the 2. So final answer is going to be negative 5x minus 12. So notice that your answer has the same slope as this over here. Different intercepts, and that makes it parallel. Okay? And I forgot to box our point slope form right there. Okay, so this is part 1, part 2. Okay, we've reached our last question, and this one has to do with perpendicular. Okay, it gives us the x and the y, which is great, but they don't give us a slope. So we're gonna take a look at this, and we're going to use the negative reciprocal of that. So it's the negative, flip the 1 over 5 to 5 over 1, and that's what we're going to use. Okay, again, we're going to use 2 different forms. So let's do the first one. So y minus a negative 4, negative 5, we don't need the over 1 part, x minus 3. So let's clean this up by doing plus plus here. So this is the first answer. Then we isolate the y by distributing. And subtracting 4. Okay. And that is it, guys. Please let me know if you have any questions. Hopefully you can do the practice test while you watch this video, and that'll clear up any doubts about procedures or what the answer looks like, and we'll go from there. So see you in class.